Right. Okay. Hope you can see the presentation. Can everyone
Yes,
see
sir.
the presentation? Now, what we are going to discuss today is the that is the header. So we'll be going to start with the first of this thing, like it is going to define about the versions. Since we will be Wireshark also, that you can understand easily. So let me, and since you have asked access to the Zoom environment, this is Zoom environment has hosted in the Learn network. So if you can reach Zoom connected Zoom environment, so you need to give your one is you have to provide the URL, that is learn dot whatever the things, and then you need to provide the credentials given by the University of Vocational Technology, and you need to select the university as well, right? So I guess you all have to done the same thing. Is that so?
Yes, sir.
Whenever you are going to log into this particular Zoom,
From the university, I hope they
you
gave a link to
did you
create.
given access to create the account. So basically, the way they are going to give it to you is they will simply provide the URL. Are like, see here right now, if you can see the most of the communications are going through the 192.248 range. This is actually, if you look at, these are the learn link. So none of the communications will happen to the outside, because none of the Zoom communications will goes to the direct Zoom US. So what they have done was they have terminated your Zoom communications through the Zoom the learn link to their learn hosted Zoom environment. So which is what they have done was they are not going to measure any data that you are utilizing for that one. So basically, because since you are using the Zoom, the Learn Lanka Education and Research Network, so they are not going to do any charges, because that is already given that consent to the all the ISP in Sri Lanka. So whatever the the communications which are going through the basically the Zoom, so they are, so not the Zoom, actually through the Learn, they are not going to charge. So that is the idea that they have done, like all the communications, the Zoom communications when it comes to your environment will be terminated on the Learn environment. That is what they have exactly done. Is it clear, guys? That's why you can see that you will be going to use, whenever you are going to use the Zoom communications, your communications will be routed through the 192.248.22.22. This is actually the if you look at the who is search, this is actually the learn communication link. Yesterday also I have told you that yesterday IP also, that is Zoom the so you can see this is again, this IP also belong to the Learn Lanka Education and Research Network. So simply what they have done was they have been terminated your Zoom communications from the Learn link. So the communication from the Learn link to the Zoom Of course, they do have data charges separately. That is not going to not going to say actually that particular charges will not going to applicable to you guys. So it's separate charges that is handled by the learn itself. So I guess, or not even for the university, Unimotech, almost all the universities who have been dealing with the Zoom environment. So because whenever you want to this, since this is a huge network, because if you can see that Zoom has a huge deal with this particular environment, because they have purchased, I guess, a huge Zoom account which can be able to cater to the at least 200 users at a given session. So that's how they have done it actually. So simply what they have done here was they they terminated your Zoom communications on the learn end and giving the access to you without data charges. So that is exactly, because otherwise in the normal Zoom account, your communications will be directly terminated to the US servers, not in here. Are you clear, guys?
Yes, sir.
So that is exactly how they are going to do, because it's up to ISP to decide what type of communications they need to measure, what type of communication they don't want to measure. So because simply the bandwidth is sort of a boundary that they have created in order to restrict your internet accesses. Otherwise, it's not a big deal. You can control everything from their devices. So they do have separate devices which is controlling your bandwidth utilizations. So that is about the Zoom communications that they will be using. Now you can see so many communications will be going through, like all the things are communicated to the 192.248.2282.2020 from my account. This is my private IP 192.168.8.103. So that's I told you, it is not going to charge the data. Are you clear, guys?
Yes, sir.
Okay. So even if you look at the source IP address destination, you can see that is the destination is going to be 192.248.22.22. Right. Okay. Let's start with the IP head analysis again. You can see the version protocol here. That is what exactly they will be discussing here. The which version of this packet belong. Since right now we don't have any IPv6, so not without having any delays, you can straight away tell that definitely the version should be the version 4, because we don't have the IP version 6. So if you do have the both communications like IP version 4 and the version 6 communications, so definitely you will be going to experience that the IPv6 communications as well in this packet capture. So that is guaranteed.
Yes,
Next,
sir.
yeah,
සර් මේ ඊමේල් එකකට එතකොට කොහොමද සර් IP එකක් assign වෙන්නේ? දැන් මගේ කම්පියුටරේ තියෙන IP version 4 එක. එතකොට
sorry.
දැන් මම ඊමේල් ආපු ඊමේල් එක පිට එක ඔරිජිනල් ගිහින් බැලුවාම IPv6 එකකින් තමයි රිසීව් වෙලා තියෙන්නේ. එතකොට සර් එතන IPv6 එක්කුයි 4 එක්කුයි කමියුනිකේට් වෙලා තියෙනවා.
ඒක වෙන්නේ මෙහෙමයි. සරලම කතන්දරේ I'll explain by Sinhala and as well as using English, that when you receive the email, if you look at the email headers are going to managed by the email relaying servers, by not by the client. When you receiving an email, that doesn't make any sense where you have received. I'll show you that. Let's think about just this particular email, right? Everyone can see this one. When you look at this email header, can everyone see this one?
Yes sir.
These headers are handled and managed by the different email servers, not by us. This is my client, email client, that is I'm using the Thunderbird. This is the mail header given by the email server. Let's say while you are receiving the email, let's think about Gmail address. While you are receiving the email, when you say show original, right, see here. You can see because since the Gmail is using IPv6 addresses, this is one of the IPv6 address. So whenever we learn the IPv6, you will be definitely learn this one. Right now also, I am not using any IPv6 addresses. So my machine having, if you want, you can check it. When you run the what is my IP address. So it's purely IP version 4, nothing else. Are you clear, guys?
Yes, sir.
This is purely IP version 4. Now, but even still, I am running with the IP version 4. You will be able to see that. In the header, when I look at the mail header, it says, this is, we call it as a mail header containing, because mail, whenever you are going to send a mail from, let's say, for example, from, let's say, you have a domain name called from myself, like suren@texad.lk to, let's say I'm going to send the mail to the in my to my Gmail, that is ssurin17@gmail.com. That is to my mail address. Whenever we are sending the mail, if I use the mail client, this is the how the mail is working. The mail will be goes to the our email server. So the nearest email server will be located on our on-premise data center, that is on our locations, our data centers. So basically that particular mail straight away goes from my client machine, from my client environment, that is goes to the mail server. So then from that mail server, then it will pass to the different type of mail servers. It might be contain one more than two or more mail servers, which is containing to relay the mail to the intended recipients. From the suren@texad.lk, definitely I can guarantee you that particular mail definitely will be routed to another at least two mail servers before reaching to the intended recipient. So while they are reaching to the different mail servers, they will be going to add the header where this mail is routed. So in these mail servers, they might have the IPv6 addresses where the mail server to mail server communication happen through the IPv6 if they both running on the IPv6 environment. So that is possible. See, this is something like that. So when you receiving the mail, there is a the mail, one mail, this particular mail has been sent from one server to another by using the IPv6, but doesn't matter whether we have the IPv4 or not, because my client and my connected nearest mail server, definitely they have to work in the IP version 4, because if they were not able to accept my IP version 4 request, that particular mail server, of course I cannot send the mail. So definitely my nearest mail server, which is they are going to accept my mail, that is has to be definitely, has to be IP version 4. But from the next mail server to another mail server communications, that can be run on the IPv6, whether it is does not matter to the recipient and the sender both, the receiver and the sender. That doesn't make any impact, because the nearest connected server will work on the IPv6 where v4, whereas in the middle relaying, that we call it as a relaying mail servers, those relaying mail servers will work on the IPv6. I'll draw and show you. I'll draw this one and show you. simple here. Let's say we have a, this is my machine. Just say this is my machine. I am having the mail in here like suren@texas.lk. Now I am going to send the mail to the remote person. He is located in here. Let's say SURAIN17 @gmail.com. That is my Gmail address. Right now, so when I starting sending the mail will be first delivered to my nearest connected email server. This is basically, in my case, this is going to be the actual in my server, submit.texas.lk. This is the name that we have given. It's just a name. You can put any name there. Submit.texas.lk. From that, they are going to put it to our next mail server that is called, actually that name is goes like a, that is our filtering mail server. So if I draw you in here, it says kukul.nic.lk. So that is the mail server that we are going to do. So from that, the mail will be goes to the outside of my data center. Then after that, I don't know where the mails goes, but that will definitely receive to the intended recipient. So in here, in this case, you can see, since I am running on the IP version 4, this is my machine. That is definitely, I am guaranteed that I am running on the IP version 4. This particular interface has to be run on the IP version 4. But in our case, from the submit to the Kukul, that is our submission server. This is our submission server. These are the two mail servers actually running on our environment. These interfaces will run on the IPv6. So the communication in between the submit and the Kukul servers, these are the two mail servers, will be happen through the IPv6, because this particular this particular server has been configured with the two IP addresses. One is the IPv4 address and the other one is the IPv6 address. I'm going to discuss how we are going to do the configurations. Nothing to. From the IPv6, from this point onwards, so of course they can be having the next interface that is going to be only talk through the IPv6. That is possible. So they are going to talk through the IPv6. But from here, they can happen through the IPv6, and it can be, this communication also can be happen through the IPv6, and finally that can be goes to the intended recipients, that is the Gmail, that is through the IPv6. You can see now. So it's a combination. So you can see in our mail communication path, some servers are supported IPv6 communication, some are supported only IPv4 communication. On those environment, while you are passing the mail, they are going to add the headers. Adding the header and saying this is the server that I have passed and this is the server that I have passed. It's like a train tablet. So you know, whenever you are dealing with the train tablets, so of course you might see that one still in some upper country railway stations and also the down south railway stations, as a tradition, still they are passing the tablets. Right now it does not make any sense actually, since we do have the digital sort of mechanical signaling mechanisms along with the railway roads. But earlier days, what they have used this the train tablet source, that is just they have updated the throughout from one station to another station, that the conductor or the driver of the train has to update the condition of the rail path, who has met and what is the status of the rail path, and everything has to be then given to simply to the what we call the next station master. So that is sort of a tablet systems that they use. So exactly what they are using here as well, it's similar to the tablet mechanisms. What they are going to do is they are going to update the mail headers stating that what are the servers that they have bypassed before reaching to the intended recipients. In that scenario, as I mentioned here, they might be able to go through the IPv6 communications and they might be go through the IPv4 communication as well. But that doesn't matter whether you have the IPv4 or the V6. Are you clear, guys?
Yes, sir.
Do you have any issues, concerns with this?
No, sir.
Let me check. See, this is that's why I told you. Um, as you mentioned, like Hutch, I'm not quite sure whether they have been engaged with the understanding of not to charge any data for the learn communications, because Mobitel Dialog and SLT1, they have in a sort of a in agreement with the university grant commissions to not to charge any data which are traveling through the learn communication channel. So I'm not quite sure whether the Hutch is in the same page, because sometimes they might not. Because but they may, because as far as they concerns, like UGC concern, I guess the 90% of the people are dealing with the SLT, Mobitel or the dialogue. So that's why they, even I'm not quite sure that Airtel also, there's anyone using Airtel internet communications. Even I'm quite doubt that do you have actually signals, that 4G or 3G signals out there, because for the Hutch, because I'm not quite sure whether they do have it. Even very hard to get the signal strength as well for the Hutch to cover the whole island. Are you getting the 4G communications, 4G signals or 3G signals for the Hutch in your area? Okay, okay, 4G.
No, sir.
Yeah, if you can try out the dialogue, not even the dialogue, Mobitel and the telecom also, definitely telecom will provide the free of charge data for the Zoom communications that is happen through the learn channels. But that might be the case because they have only they might be reached, the UGC also might only reach to the three major ISPs only, rather than going to the other ISPs as well. So it's better if you can change the link actually. Are you clear, guys, this particular communication, email communications?
Yes, sir.
Yeah, I'm also not quite sure. Hutch is pretty much stable connections that you can get it, because there might be some unstable issues with the, not even for the Hutch but also for the all the other communications as well, like if you take the any type of things like dialogue, Mobitel, anything. Let me try that one. Okay, so right, so are you clear what we have gone through up to now? Do you have any issues, concerns, so we can clarify? So guys, these are actually this is I'm because the questions that you have, what about the email solutions, I'm pretty much uh, actually I can say that I am expert on these email solutions providers, like I have done with the different type of email implementations in Sri Lankan context, most probably in the larger companies, like there are larger companies that I have done the email implementations. Most of the time, the 90% solutions of 90% of the solutions that I have deployed with the open source, like Simbra and the Postfix, Dopot, Qmail. There are so many things, and Exchange also I have done some implementations with several companies. That's why I can give you explain how this is working, right? Okay, so if this is clear, let's go move back to the presentation. Right. So here what we are going to deal with is most probably you will be getting the assignment today. Let's check that one. Yeah, yeah. Yes, yes, yes. Right. Okay, guys. So so the version that we will be discussing here is the IP version 4. Of course, that is nothing else. So we can do anything. We don't have any other IP versions that is enabled in our environment, since we are not having that particular content. So with the IP version 4, that is the first part of the header, that is having the containing the 4 bits. Like say for example, if you look at this IP version 4, you can see that it says 45. Whenever you go to the next one, it's still highlighting the 45 in this pane. Can you see that one, guys? Guys, hello.
Yes, sir.
Yes, sir. So can you able to see this one? Like, guys, I need your feedback because I just talking the technical content. If you didn't get the content properly, then we need to go through it again and again, because I need to give you sound knowledge, deep knowledge on this particular area. Even again, another thing, like I have shared a free Red Hat training course. So if it is better if you can go through that one as well. Still, since you are novice to the Linux environment, so just go through the Red Hat system administration courses, like the initial courses, not to think about going with the advanced courses like Ansible, OpenStack. Those are just advanced courses that which is not going to work with you, because you don't get any understanding even though you go through those courses. So just to get the idea, what is the Red Hat and how it is going to be, not even the Red Hat, what is the Linux and how it is going to work. So just go through the first modules like Linux, the Red Hat system administration courses. So we'll be learning several important things there. So if you're interested, only you should go through, because this is a sort of a like uh, what we call is as a silver line in the dark cloud. The same thing apply to here as well. So you have a silver line that you can learn so many things. So of course the cloud is dark, there is nothing to do, but we can create a silver line out there. So just to get the idea that if you want to get the overall technical knowledges, the reason that I'm saying that, when we go for the interviews, so this is applicable for the almost all the universities in state sponsored universities, like not even you guys, but also the other universities, Morotua, Kalambu, Japura, any type of universities. If you compare the the student who have passing out, who is passing out from the state university, and who has passed out from the private university. especially this NSBM street type of universities, they have at actually they have extra knowledge when you compare with the state university students. The reason is they will give you the some institute, actually those universities will give you some industry certification courses, and they will offer the some industry certifications like Docker, container concepts, Kubernetes concepts, cloud environment concepts. So whereas since the state universities are stuck with this traditional learning mechanisms, learning method, they don't follow those things actually. They are not changing their curriculum according to the industry the demand. So that is the major issues that I'm seeing with especially the state sponsors universities. But it's again, you have the responsibility to learn by yourself. Obviously that is on your hand to learn those things. So that is the major thing that I need to highlight here, like guys. That's why I'm even sharing these training modules as well, because otherwise you don't get any sort of a updated knowledge on this regard. So please guys, please just update your knowledges while you are in this same session. Right. So that is about the Linux. That is just to give you the idea on this particular environment. So please keep in mind that always get the extra knowledge, learn the extra knowledge, learn from the internet. Most of the time you can learn it from the internet. Of course, the university will give you the base knowledge to build up your career. The rest you have to do. So anyway, that is up to you to decide whether where you going to do, where you end up your career. Again, I'm telling this one because the reason why I'm saying here is I don't see any persons who have been like what we call who has been shown their colors. Like we can proudly say that this is a product from the Uniotech. So that is the one of the major thing that you need to build up. So if we can say this is product from the University of Vocational Technology, that is what you need to build your colors. So exactly that is what you want to do. If anyone says like by hearing your name, so okay, this is one of the best guy that we can give the job to him. So obviously that you have achieved what you want to achieve. But if you when someone heard your name, so it's just a waste of everything. So that's what you need to achieve is your colors in the industry. Keep in mind that one, guys. Huh? Right. The next thing you can see now. So always all the lectures in your university will give you the fullest support to get to that place, but there is a 50% of the unit the students also responsible for taking up to that to level. So anyway, guys, so can you just look at this one? Whenever I just click on this two link, whenever I change this one, you can see that is changing the highlight point. So here you can see that it says that the version is 4, that is having the same here in here also, and when you click on the header length also, that is having the same. So the reason is this 4 and 5, this 2 digits will representing 1 byte. 2 digit in here will representing 1 byte. That means 1 digit will representing 4 bit. So if you look at the 4, here also the version 4, it's a 4 bit size of, so it's a size is here is the 4 bit. So that exactly this is the 4 bit. So the next header length is also the internet, or we call it as IHL, or we call it as an internet header length. That is also shown by the 4 bits. So what is the meaning of the 4 bits? Guys, what is the meaning of the 4 bits? Guys, I need your answers. That the last one, that is the internet header length, this particular 4 bits, what is the meaning of this header length? IHL or HL? Guys,
4 bits means
that is the internet header length.
header length.
Yeah.
Is that mean IP header length and internet header length are the same one?
Yeah. The when you look at the packet, so when you say IP header length or the internet header length, both are referring to the same. So header length. So normally the header length will be vary from 20 bytes to 60 bytes. This is the packet, the IP packet size. So this the minimum size which can have is
5.
20 bytes. The maximum size that particular IP header or the particular data pack, this particular IP header can have is IP version 4 header. Maximum size which can have is 60 bytes. So are you clear, guys?
Yes, sir.
What about the others? I need your clear feedback, because as soon as we finish this one, there are going to be a assignment that is again tough one, and which is going to be having 10 marks for this assignment. Keep in mind that 10 marks. So just give me the crystal clear idea about it, whether you are cleared with this or not. If you have any doubt on this, please let me know, then I can explain it again. So you can put in the chat also, nothing to worry.
සර් ඒ කියන්නේ ඉන්ටර්නෙට් හෙඩර් ලෙන්ත් එක 5ට වැඩි අඩු 20ට වැඩි අඩු වෙන්න බෑද?
අඩු වෙන්නේ නැහැ. 20 තමයි minimum size එක. So minimum size of the header length, that is 20 bytes. So it is not less than that. It is not less than that.
සර් එතකොට මම දැක්ක ටියුටෝරියල්ස් පොයින්ට් එකේ තියෙනවා අර ඔප්ෂන් කියලා අපේ කොටසක් තියෙන්නේ උතන යටම ඒ ඉන්ටර්නෙට් හෙඩර් ලෙන්ත් එක 5ට වැඩිය වැඩි නම් ඔප්ෂන් එක වැඩ
internet length එක මට තේරුන්නේ නැහැ.
ඉන්ටර්නෙට් හෙඩර් ලෙන්ත් එක 5ට වැඩිය වැඩි නම් ඔප්ෂන් එක යූස් කරනවා කියලා ඒක මේ අමතරව සිකියුරිටි පිළිබඳව
5ට වැඩිය header length එක 5ට වැඩිය වැඩි නම් කියන්නේ.
සර් මම මේ ස්ක්‍රීන්ෂොට් එකක් දාන්න ඒක. එතකොට
ඔයා කියන්නේ bytes 5ට වැඩිය වැඩි නම් කියන එකද?
bytes නෙමෙයි සර් මම කියන්නේ value එක.
මොන value එකද?
ඒක නම් දන්නේ.
ඔය එවන්නකො බලන්න. Right, I'll explain this again. I'll explain this again.
හරි සර් මම ඒකේ සර්ට දැම්ම මැසේජ් එක.
No. This is what they are mentioning is the options field actually. So this is not exactly the internet header that they are going to talk about. It says actually, yeah, options can be definitely 0 to 40 bytes. That is guaranteed. I'll miss, but I'm not quite sure if the value of IHL is greater than 5. What is that value they are mentioning here? Just give me a second, guys. Yes, someone raised hands. What is the issue? I'll explain that one. Just I'll explain that. What is that 5 number? What they are saying? Just give me a 5 minutes, guys. I'll explain it. Huh? Okay, just 5 minutes break. Okay. Okay, guys. Right, we'll start. This it's very hard to continuously talk. That's why I'm taking breaks on here. So anyway, whenever we want to discuss this one, so I'll explain again. So the first, the IP header. If you look at the horizontal cut on the IP header, you will be seeing something like this. Sorry, it's a vertical cut. So you will be seeing something like this, which is first 4 bits will assigning you the versions. The first 4 bits will assigning you the versions. Are you clear, guys? So that means whether you are using IP version 6 or the version 4, you can see that different type of IP versions will be available here. That is, you can see that is having the IP. So I'll just stop this one. So you can see the first 4 bits will be defining the IP version, right? So the second one will be defining the header length. Header length in the sense, this header length, what they are going to say is the IP data packet size. The header length will be exactly equal to the IP data packet size. Are you clear, guys? Do you have any issues, concerns? So what they are saying here is when you say header length, that is going to be the IP data packet size. So the data packet size of the IP will be vary. The minimum size of the packet size can be have 20 bytes. You can see in here, it says 20 bytes. So within the bracket, you can see the number 5. I'll explain that one. So it says 20 bytes. So most of the data packet size is 20 bytes. You don't see more than that. That is the minimum size. That is the most probably that is the size that you are going to look at even in the live environment. Look at this. It is not more than the 20 bytes. You can see that it's always 20 bytes. But when you dealing with this IPv4 header, you might experience that. There is a, if you look at here, there is a extra additional field called options. Whenever, if you don't have any options, that is the 20 bytes size. That means you don't have any options there. That is the size of the 20 bytes, which include these header details only, except the options. But some data packets might contain the options. If they have added the options to the IPv4 data packet, I'm just trying to show you that one. With the extra options, that means the size will be more than definitely 20 bytes. The size of the data packet, the IPv4 header, might be goes up to the until up to the 60 bytes. Are you clear, guys? The data packet might be goes up to the 60 bytes. Are you clear, guys?
Yes, sir.
What about the others who
Yes, sir.
has not
Yes, sir.
cleared previously? Yes. So can rest of you guys also tell me whether you are cleared or not?
So is that mean
I didn't hear you.
in the header for
Yeah, Nisal,
store the
yeah, I can't hear you properly, Nisal.
can you hear me now, sir?
Yes.
Is that means in the header of the datagram 4-bit use
IP.
huh?
IPv4 header.
Yeah, IPv4 header 4-bit used to store the version just like IPv4 version
Yes.
information,
Yes.
and 4 bits used to IP header length.
Yes, 4 bits used for the IP header length.
Uh,
That is to store the information, huh? Not to any other thing, store the information. So this IPv4.
okay, sir. That means totally 8-bit used to store the information including version and the header length.
Yes. That is
Okay,
what here you can see.
okay, sir.
They have reserved exactly 1 byte because 8 bits exactly equal to 1 bytes. That 8 bits will be allocated 4 bits for the version.
Totally 4 bytes.
Another 4 bits for the header length. So 1 byte will be definitely reserved for the, that is mean 8 bits will be reserved for the version and the header length. Version and the header length. Are you clear, guys?
Yes, sir.
Okay. So the next thing that we will be going to look at, so here, since you have asked, like, you can see whenever you set to the 4 bytes, it's exactly set into the 5. So the 5 is just a number. What they are saying here is, let me check whether we have any more than 20 bytes. No. So if you, I'll show you. If you say 20 bytes of 20 bytes, now we say that we are going to store the data, which is 20 bytes of the data. So if you take 20, if you say 20 bytes, what is the bits value of the 20 bytes?
Uh, 160
So 8 into, because one byte will be equal to 8 bits. So 8 into 20, that is exactly similar to the 160 bits. So exactly similar to the 160 bits. Is it clear, guys?
Yes, sir.
Right. So when you say 160 bits, what they are going to do here is, so they will be going to use simply in this is how they are going to use it. They are going to use 4 bits to store the header length. Actually what they are going to store here is 32-bit size of data. Sorry, 32-bit size of data in each and everything. So 32-bit size of words. So whenever they are going to store your header length, what they are going to store here is, they will be going to store the 32-bit of words in that particular header length. That means if you look at 32 into 5, exactly equal to 160 bits. 32 into 5 exactly equal to 160 bits. What they are saying is, that is the minimum value. You can see, if you see, that's why it says 5 here also. That's why in here also it says 5. If the internet header length is greater than 5, definitely that is a option field is enabled. So they do have a options field in this one has been enabled in here. Is it clear, guys? So that is what they are saying is, so whenever you are going to store the data, what they are going to do is they will be going to store the 32 bit of words on the 4 bits that specify the number 32 bits words in the header. So if you look at the 32 bits of words, so that what exactly we are going to say is 32 into 5 will be equal to 160. So I told you that minimum size that is which can have on the IP header is the 20 bytes. 20 bytes, that means 160 bits. So that means exactly 32 into 5. That means if the header length is more than 5, that is the sort of a value that they have assigned, or you can say if the packet data size is greater than 20 bytes, or if your packet data size or the header length is greater than 160 bits, that means definitely it contain the options. Are you clear, guys? Because if it is more than 20 bytes, in the sense that should contain the options, until up to the 60 bytes they are going to add the different options. Are you clear, guys?
Sir, මෙතන sir මෙතන 4 bits ද නැත්නම් 4 bytes assign වෙනවා.
කොතනද
මේ sir මේ තියෙන මේ note එකේ 4 bits equal to
4 bits ඒක 4 bits එන්නේ bits 4 assign කරන්නේ ඒකට bytes නෙමෙයි.
ඒතර ඒකම convert වෙනවා 32 bits වලට.
නෑ convert වෙන්නේ නෑ. මෙයාලා කරන්නේ මේ 4 bits ඇතුලේදී මෙයාලා store කරන්නේ දැන් 32 bit words කියන එක. දැන් ඒ කියන්නේ නිකන්
characters ද නැත්නම්
characters වගේ එකක් තමයි. ඒක මේ ඇත්තටම දැන් අර CPU එකේ තියෙන concept එක characters වගේම තමයි. characters වගේ තමයි. 32 bits words කියන එක.
Thank you, sir.
Right. So are you clear, guys? So it's a simply 32 bits words in the sense the characters, just the number of characters. So that's why we says, but here even you can see here in the header also you can see that either you can set to the length of 20 bytes or you can say 5. It's just implied the 20 bytes in simply. So if your data size is more than 20 bytes, because the 20 bytes in the sense what it contains from the versions to until up to the destination IP address. But if it is contain more than 20 bytes, that means it should include the options. Right. So that is actually what we are saying is the internet header length for the versions and the internet header length. The next thing is which is containing 8 bits. That is we call it as this contain 8 bits. 8 bit contain two things. See here you can see this containing 8 bit exactly 1 byte. 8 bit contain two things. One is differentiated service field, that we call it as the differentiated service field. The first 6 bit, I'll explain that one also. So we call it as a toss. The next field that we are going to do is a toss type of services, which contain exactly 8 bit on the IP header. So this 8 bit will be broken into two bits level. That is one is 6 bits, the other one is 2 bits. That is containing 6 bit containing DSCP values, and these 2 bits containing explicit congestion notification, ECN values. So this two, simply this field type of services, by the name it's given, the actually what they are going to show is QoS, quality of service. In order to increase the quality of the service on the IPv4 data packet. Let's say, for example, when you send the data packet will be, let's say, for example, while it is traversing through the routers and different type of network layer devices, sometimes the data packet might get queued in order to process. So what you can do is, so in here, whenever you want to deal with that one, you can say something like this. You can simply say, I want to prioritize IP data packet A and the B and send it immediately. So the rest of the data packet can be used the normal standard normal prioritization mechanisms where treated everyone equally and normally process the queue. So likewise, whenever you want to prioritize the data packets while you are sending through the routers, while it is queued in the routers, so obviously it is possible to do it in this manner. So the QoS, quality of the service, type of service, that 8-bit will contain those things. 6-bit of DSCP values, differentiated service values, that we call it as the 2-bit of explicit congestion notifications. That means if there are any collisions while you are receiving the data packet, that has to be informed the receiving party. That is what they are going to do with the explicit congestion notifications. Are you clear, guys? If there are any collisions while you are receiving the data packet, because we just think about, when you look at the larger networks, we are just not talking about sending one data packet per second. We talk about sending gigabits of data, including the data packets, IPv4 headers per second. So in that scenarios, the congestions can be happen within the network. So if there is any type of congestion happen, conflicts happen, so they should receive, the receiving party should get notified about it. So that is called explicit congestion notifications, or rather we call it ECN. So there are two type of services that we will be looking at in here. In most of the cases, these are zero values. If you look at here, the differentiated services and the ECN services, even though we say 8-bit, so you can see it's all are 0C. Different DSCP in the sense differentiated service code point. This is what exactly naming by the DSCP. Differentiated service code point. Are you clear, guys? ECN stand for explicit congestion notification. Explicit congestion notification. So you can see these things. Are you clear, guys? Do you have any issues, concerns with this?
So ඒ කියන්නේ අපි යූස් කරන ස්ට්‍රීම් එකට අනුව එතන කෝඩ් එක වෙනස් වෙනවා සර්. දැන් ඔඩියෝ මොකක් හරි වගේ දෙයක් නම් එහෙම වෙනවා.
ඒක වෙනස් වෙන්න පුළුවන්. සමහරලාට prioritize දීලා ගියොත් ඒ කියන්නේ you just think about that you are dealing with IPsec tunnel, so we call it as IP security. If you implement that the IP security, of course there will be DSCP values included in that area. So it's based on your data packet that you are receiving might be definitely changed, but in our case we don't have any changes in here. But we can see whether when you trying to reach Because most of the time they will be dealing with the default values rather than adding the QoS. Let's say, for example, some firewalls will support to add the quality of the services. You can do the fine tuning the quality of the service. In that case, they are going to change the values. That is possible, but you require the devices, something like firewalls, routers, in order to add the DSCP value to the IP headers. Are you clear, guys?
yes sir. ඒ කියන්නේ සර් මේ දැන් අපි රවුටර් එකක් වගේ යූස් කරද්දි ඉන්ටර්නෙට් යන ගමන් අපිට ඒකෙන් කෝල් එකක් આવුත් අර රවුටර්ස් වලට මේ එතන තියෙන මේක වෙනස් වෙනවානේ ප්‍රයොරිටයිස් ට්‍රැෆික් එක ගන්නවා
routers call එකක් આવුත් වෙනස් වෙන්නේ නැහැ. ඒ කියන්නේ ඒක ඔයාලා එහෙම කරලා තිබ්බොත් විතරයි වෙනස් වෙන්නේ. So if you have done that, so then only that is going to change, because we cannot exactly tell that they are going to change it with the routers. So for the voice communications, because right now even we are running the voice communication here also, but that doesn't make any sense. Clear, guys?
okay sir, yes sir.
Do you have any issues, concerns which related to this one? Guys, do you have any
example
issues?
එකක් විදිහට එතකොට කොයි වගේ වෙලාවටද ඒක වෙනස් වෙන්නේ සර්?
That's what I told you. Whenever you are going to deal with the, let's say for a firewall, let's say we are dealing with the concept called QoS. In the firewall, we can do the QoS. What we can do is we can prioritize the some traffics. Let's say, for example, if we want to prioritize the Zoom, like say for example, in your university, they might, whenever they are going to done the QoS for the link, they can prioritize the Zoom traffic. So that means all the other traffic will be considered as the low priorities, whereas only the Zoom traffic will be considered as the high priorities. In that case, definitely they are going to change the values in that. Clear?
oh sir, yes sir.
So again, ඔයාලා සරලවම ඔයාලා හිතන්න දැන් Zoom එක prioritize කරනවා ඔයගොල්ලන්ගේ network එකේ. මොකද ඒකෙන් තමයි ඔයගොල්ලෝ internet යන්නේ මේ sorry communications වෙන්නේ. Sorry guys. Communication වෙන්නේ. එතකොට prioritize වෙන්නේ ඔයාලගේ මේක DSCP value වෙනස් වෙනවා එතකොට ඒකේ. ඒ අදි Zoom වල. දැන් මෙතන අපේ මුකුත් එහෙම කරලා නැහැ නේ අපි by default network එකකනේ ඉන්නේ. ඒකයි. අපි බලමු මේක හැබැයි වෙනස් වෙන්න පුළුවන්. Sometimes that is not going to change. We see that one. So still we are seeing the right. Okay, guys, can you hear me?
Yes, sir.
You can hear me. So let me check that one. I see. So still we don't see any, because even I'm accessing the YouTube also, I don't see any yeah, let's still that is running with the Yeah, they don't do any changes because we are not in a sort of environment where we should prioritize it. Are you clear, guys? But if you are dealing with the most probably the enterprise environment, so there we do the some traffic prioritization. That is we of course do. Yeah, that is of course we do. Okay, see here. No, it's also see. Sorry, not done, guys. Not done. I don't see anything. No. So that's just to give you the idea that I want to show you here. But anyway, that is not possible with this differentiated courses like DSCP. And this is, as I mentioned, this particular changes will be happen when you have done the traffic prioritization by using the firewall type of devices. So using the router type of devices, that is possible. Let's say if you have prioritized the Zoom traffic, of course, that will be adding the different type of DSCP values and ECN to the data packet header. Are you clear, guys?
Yes, sir.
Right. So this DSCP, you will be seeing that this can have the different values like D, T, R, C. If they have enabled the D, that is the minimize the delay. So by minimizing the delay, they need to send the data traffic, that data packet. So that is, we call it as prioritization. T, maximize the throughput. That means they will be zip the data packet, or they will be try to compress the data packet and send it that by maximizing the throughput. R, the maximize the reliability. That is the R. C stand for the minimize cost. So DTRC stand for different type of values that you can add it to the differentiated DSCP codes, differentiated service code points. So the minimize delay, maximize throughput, maximize reliability, minimize cost. Cost in the sense in term of bandwidth utilization. Now this is not the money. This is they talk about in term of bandwidth utilization. So those are the different type of code values that they can use it here. Are you clear, guys?
So can you explain signal is?
Yeah, I'll explain it. So just give me a second, guys. Right. මේක වෙන්නේ ඔයාලා IP header sorry type of services කියන එකේ values දෙකක් තියෙනවා. So එකක් තමයි DSCP කියන එක, that is called as differentiated services code point. අනිත් එක තමයි එකට 6 bit sign වෙනවා. අනිත් එක තමයි explicit congestion notification 2 bit sign වෙනවා. ඒ දෙක ඔය කියපු ටික තේරුණාද ඔයාලට?
ඔව් සර්.
හරි. මම මේ කියන්නේ ඒ DSCP code point වල තියෙනවා, ඒ කියන්නේ service එක වැඩි කරන්න. දැන් service එක වැඩි කරනවා කියලා කියන්නේ prioritize කරනවා. traffic එක prioritize කරනවා. You can tell that one in the router එකක කියන්න පුළුවන් zoom එකට යන traffic ඉක්මනට යවන්න, අනිත් traffic internet access කරන අනිත් traffic සාමාන්‍ය path එකේ normal priorities දීලා යවන්න. එහෙම කියන්න පුළුවන්. එහෙම කිව්වට පස්සේ එතකොට priorities දීලා normal path එකේ යවනවා. අර zoom traffic එක prioritize වෙනවා. ඒ prioritize කරද්දී ඒගොල්ලෝ කරන්නේ මෙන්න මේ values ටික. මෙතන service type එකේ service code point වල තියෙන values හතරක්. D, T, R, C කියලා. D කියලා කියන්නේ minimize delay කියන එක. එතකොට තමයි priority වෙන්නේ. delay එක minimize කරලා ඉක්මනට යවන්න. D. T කියන එක තමයි maximize the throughput. ඒ කියන්නේ throughput එක වැඩි කරලා යවන්න. ඒ කියන්නේ එතකොට bandwidth utilization එක ඉක්මනට වැඩිපුර කරන. ඒ කියන්නේ 1 Gbps එකේ ලොකු data packet ප්‍රමාණයක් යවන්න පුළුවන්. maximize reliability. එතකොට ඒක කරන්නේ data packet එකේ reliability එක වැඩි කරලා යවනවා. ඊළඟේ තමයි minimize cost. cost එක අඩු කරලා යවන්න. cost එක කියලා කියන්නේ bandwidth utilization. සල්ලි වල නෙමෙයි මේ කියන්නේ bandwidth utilization. මේතෙන්දි වෙන්නේ මිනිමයිස් කරනවා cost එක bandwidth utilization වලින් cost එක අඩු වෙන. ඒ කියන්නේ data packet එකක් යවන්න යන වෙලාව ගොඩාක් අඩු කරලා යවනවා. ඒක තමයි cost එක කියන්නේ. ඕක තමයි සරලවම type of services වල කරන්නේ. Are you clear now guys? දැන් තේරුණාද?
yes sir. ඒ කියන්නේ sir මේ දැන් මේ data packet වලටත් අර මේ computer එක process වගේ prioritize කරන්න පුළුවන් නේ sir.
ඔව් අනිවාර්යයෙන් පුළුවන්. ඒකනේ මේ QoS වල කරන්නේ. අපි ඔය firewall වල link QoS ඔයගොල්ලෝ live firewall දානකොට ඕගොල්ලෝ කරන යන දෙයක් තමයි quality of the service වැඩි කරනවා. link වල QoS එක කරනවා. link QoS කරනවා කියන මේක තමයි කරන්නේ. එක එක traffic යනවට ඒවට priority දෙනවා. සමහරලාට අපිට දෙන්න පුළුවන් Zoom එකේ traffic එකට priority. සමහරලාට දෙන්න පුළුවන් මොකක් හරි ඕගොල්ලෝ Office 365 access කරනවා නම් ඒකට priority දෙන්න පුළුවන්. ඒ වගේ priority වැඩි කරනවා. Clear guys?
Yes, sir.
yes sir.
yes sir.
Right. Right. So we'll move into the next. The people who are in the Tamil medium also, are you clear? Just give me the clear. If it is clear, just tell me. Then if it is not clear, you can ask the clarification again. The people, because someone has asked me to explain with the Sinhala, that is fine. So I explain it. If you required any explanations, even the other people also, please guys, people who's talking with the Tamil language, nothing to worry. So do you clear with this? I need to ask this one from you guys as well, because I don't get any feedback from you guys. Let me see who are the Tamil people in here. Fatima Rikasa, are you clear?
Yes, sir.
Okay, sure. Ahmad and Triple A Ahmad, are you clear, guys?
Yes, sir.
Okay, okay. Okay, so who else? Hamsat, what about you?
Yes.
So where's our Tamil friends? Rais Mohammed, just make in mind of the race film actually. Rais Mohammed, are you clear? So where's our Tamil friends? We don't have any Tamil people in here. Don't we, or do we? Because I only see the most of the names, either the Sinhala or the Muslim. J Vinushan. Vinushan, I guess it's a Sinhala name, right? Don't we have any Tamil people here? I guess we do have Tamil people, right?
Yes, we are here, sir. We can understand.
Okay. So better you can put your name, because I can't call you by the index numbers. So if you can put your name, that is good. So I guess everyone is clear with this clarification. So obviously, if you required any further clarifications, you may ask. So otherwise, we can proceed with the others, the rest of the part.
Yes sir.
Okay, guys. Right. So then continuation of the same thing, that is toss of the bits. You can see that if you see the normal default options on the type of the services, that should be the all zeros. You can here see that one. All are set to zeros. See, all the 4 bits are set to zeros. That is the default one. Normal one, no any quality of the services enabled in this particular IPv4 headers. If you want to minimize the cost, that will be 1001 0001 0001. If you see this one in here, that is minimizing the cost. Unfortunately, I can't show you that type of example here, because everything is going through the default normal prioritization, where just treated everything as equal. That's why. So you can see, even I can't see anything in here. Unfortunately, that is not possible to see. Yeah, yeah. See, if you can see here, everything is 0. That is the default. But sometimes you might see the 0010, like something in here, 001. In here, it should be 1 and 0. That if you see in like that, that is going to be the maximize reliability, maximize the reliability. If you see the 0100, 0100, so that can be the maximized throughput. That is the maximizing the throughput. And if you see the 100, 1000, that is the minimize the delay. So likewise, you can see the type of services bits. So or differentiated service point points, DSCP, which is going to be discussed about the type of services or the quality of the services on the IPv4 data packet. So the explicit congestion notifications, like when you say if there are any collisions in between the transport, that will be notified the recipients while they are receiving the data packet. So that is the type of services which contain the 8 bits. Again, summarizing, it is containing 8 bits. 6 bits will define you the differentiated service port points. That is we call it the DSCP, or rather it will give you different type of DSCP codes like this and like here. And then the rest of the 2 bits will be defined in the explicit congestion notifications. That is, we call it as ECN. Are you clear, guys?
Yes, sir.
Right. So once you go that one, so you can see we have defined the versions, header length, service, and the next thing is we are going to use is the total length. When you say the total length, total length in the sense it define you header plus the data. See, when you say total length, it define you header plus the data. So sorry. When you say the total length, the next field that we are going to define is total length. It define you IPv4 header size plus the data size that you are carrying out on your IP, that particular data packet. Header plus data. Are you clear, guys?
Yes, sir.
Right.
Yes.
When you're dealing with this environment, you need to keep in mind the total length might be vary from 0 bytes to 65,535 bytes. That is the maximum size. So the minimum size here also, they can carry out through any network, any type of networks. That is the 0 bytes to the 65,535 bytes. So it's minimum size, maximum size to the minimum size to the maximum size, which can be carried out by any data packet in any network environment. Because when you talk about the network environment, there are different type of network environment. So it can be the Ethernet environment, like whatever you say is you will be deploying the network by using the switches and the RJ45 cable and the Cat 5E or the Cat 6 cables. So you can say RJ4, you can have the RJ45 cables. Sorry,
Excuse me, sir.
RJ45. Sorry, yes.
Sir, header length එක minimum 20 වෙනවා නම් මෙතන 20 බිංදුව වෙන්න පුළුවන්ද?
නෑ බිංදුව වෙන්න බිංදුව නෙමෙයි 20 තමයි. නමුත් මම කියන්නේ data packet එකේ size එක බිංදුව ඉඳන් theoretically define කරලා තියෙන්නේ එහෙමයි.
Okay, okay, sir.
So it's just theoretic. What they have defined is theoretically defined like 0 to 65,535 bytes. Obviously, if the header length is the minimum is 20 bytes, definitely the minimum size should be 20 bytes. That is exactly correct, that your argument. But what they have defined here is just as a sort of a sake of defining the theory, it says it can be the 0 to 65,535 bytes. So by the sake of defining it, but actually the minimum size should be 20 bytes, because obviously that is correct. But for the sake of defining that one, what they have done was they says in theoretical manner, the data total length can be vary from 0 bytes to 65,530 bytes, but actually that has to be, the minimum size has to be set to the 20 bytes. So because at least the minimum IP header size should be 20 bytes. Without any data, the total length should be definitely 20 bytes. Are you clear, guys?
Yes, sir. That means 0 means there is no packet.
Yeah, that's simply 0 means no packet actually. Yes, that is correct. Do you have any issues, concerns so far? Guys?
Yes, sir. Okay. But I don't know about others.
Yeah, that is
They are
important
silent.
thing. So just let me know whether you are correct or not. So you are you clear with this or not? Just give me the feedback, guys. Guys, please, I need your feedback.
Yes, sir, no problem.
Okay. Right. So then the important thing that we are going to learn it here is total length here is the total length size, again, as I mentioned you, that will be changing based on the type of network implementation that you have done, whether you have used the Ethernet implementation like using the Cat5 Cat6 cables, or token ring, or fiber optics channels, fiber channel implementation. So what type of method that you have used, the sorry guys, just excuse me, you guys. Sorry guys. So whenever you are going to deal with this total length, there is a one limitations on the based on the technology that you are using. Based on the technology that you are using, it can be the Ethernet cable like normal RJ45, Cat5, Cat6 cables like what we are right now using. That type of network environment can be defined, or you can have the token ring environment, fiber channel environment. Likewise, you can have any other environment that we will be defined here. So based on that, on each and every network communications, there is a value called MTU. Do you know what is this value? MTU. Do you have any idea?
No, sir.
That stands for maximum transmission unit. That is exactly called as a MTU. That means there is a limit that the maximum data size that you can be sent on per packet. That is per packet. Packet එකක යවන්න පුළුවන් data size එක. When you sending the data through the network, so there is a limitations that is defined by the different type of network cablings, network mechanisms, that is called MTU, that is says maximum transmission unit. In a Linux environment, you can see the MTU values which are limited for the particular adapter by running the IP space A command. When you use this one, when you use look at this the particular wireless adapter content, you can see they have defined the MTU values as a 1500 bytes. This is for the Ethernet. So when you're dealing with the Ethernet like Cat5, Cat6 cable wireless environment, so these values, they have maximum size of 1500 bytes. Let's say for example, if you are going to send more than 1500 bytes data packet, let's say you are trying to send the 3000 bytes of data packet through the Ethernet network, what is going to be there? Plus, let me give me the answer that whether it is possible to send the whole 3000 bytes data packet along as a single data packet through the Ethernet network. Does it possible?
No, sir. Impossible.
Okay. So what is the reason?
So maximum the 1500 bytes.
Yeah,
So we can't transmit bigger than this size.
exactly correct. Exactly correct. So since
But I think can divide or
yeah, that's
So what about
exactly correct.
multiplexing? Is the multiplexing used for this kind of thing? So
not the multiplexing, that is called fragmentation. So I'll explain that one.
okay.
So exactly what we are going to use is, we cannot send the 3000 bytes data, that is guaranteed. What they are going to do is, in the IPv for this particular network environment, they use the concept called, especially in the IPv4 header, they use the concept called fragmentation. The fragmentation done by the in the network layer. Before they are sending the data, data will be chunked into the exact same size that they can, the size that they can set it. 1000, that they will be chunked that particular data set into the 1500 into 2, 3000 bytes. So that is the, we call it as a fragmentation. In the technical terminologies, with this particular chunking part, we call it as a fragmentation. So when you're dealing with the token ring fiber channel, and they do have a different limitations. Even you can see in my wired adapter also, in the Ethernet card also, that is the maximum transmission unit that they are supporting is 1500. Wireless adapter also supporting 1500. Definitely guaranteed that if I'm trying to send any data more than 1500 before sending those data, clear guys?
yes, sir.
Yes, sir.
Right. So that is called the MTU values. If you look at the MTU values on the, let me check, I'm not ASI here. So if you look at the token ring MTU values, that MTU values will be supporting 17,940 for the 16 Mbps speed channel. token ring with the 4 Mbps speed channel that is supporting 4464 MTU. For the fiber channel FDDIs, they will be supporting 4352 maximum transmission units. Ethernet, that is, we of course know, since we are all are running with the Ethernet environment, they are supporting 1500 MTU bytes. These are the bytes values. Hyper channel, they are supporting the maximum value, that is 65,535, where I don't even have the experience with these type of MTU values. X.25, that is, they are supporting 576. PPP, point-to-point protocol channels, that is, when you create in the point-to-point tunnels, they are supporting 296 bytes of MTUs. These are the different type of MTUs which are supported by the different type of network implementations. Are you clear, guys?
Yes, sir.
So that this is what I want to show you. The next item, that is, we call it as a total length header, which is containing 16 bits. You can see, if you look at the size of these 16 bits, it is very much equal to 4 into 4, 8, 8 into 8, 16, 16 into 16, 32. So here we do have 32 bits of data in this particular IP header. So next we will be going to another one is the next layer, that is, we are going to discuss these three things together: identifications, flags, and the fragmentation offsets. These three things will belong to whenever you will be doing the fragmentations, because I told you that we have limitations on the Ethernet channels, or not even the Ethernet channels, when you're dealing with the different type of channel environment, different type of network implementations, different type of network protocol like fiber channels, hyper channels, token rings, X.525, you name it, PPP protocols, Ethernet protocols, so you name it. So there are different type of limitations that the maximum data packet that we can send it. When you say data packet, it includes all the headers plus the data. Keep in mind, when you say data packet, it includes all the header plus the data. Are you clear, guys?
Yes, sir.
Right? So when you say in this total length, it includes the data plus the IPv4 header. So keep in mind that when you're dealing with this, so it's going to be include data plus the IPv4 header. So the IPv4 header, you can take it with the 20 bytes. Total length, when you say, let's say for example, so there is a calculation as well. If you look at the total length here, total length they are saying as they are going to say as 60 bytes, the total length, and then they are going to say, okay, total length is the 60 bytes, and the I header length is, or IHL, or rather we call it as a header length. Header length, they are going to say 20 bytes. Can you tell me the what is the size of the data that they are carrying out in this particular data packet? Size of the data.
40 bytes.
Exactly. So I told you this is the equation. Total length will be equal to IPv4 header size, the data size. So if you want to take the data size, just deduct the total length capacity from the header length size. So of course they will give you the data size capacity as 40 bytes. Are you clear, guys? Let's look at a practical example here. Let's look at the practical example here. So now you can see here, we are having 20 bytes of the packet header. The length of the data packet is 795 bytes. This is the byte, 795 bytes. Can you tell me the data size of this data packet? Guys, I need your answers.
775.
775, exactly. So let's take another answer. So let's take another one. See here. So it says the total length is 252 bytes. The header length is 20 bytes. Just give me the size of the data that they are carrying out.
232.
232.
230.
232 bytes, yes, 232. In here, Header length is 20 bytes. Total length is 154 bytes. What is the data size of this packet, this particular
130
packet?
134 byte.
134 bytes. Here. So it says total length is 86 bytes. The header length is 20 bytes.
66 bytes of
66
data.
bytes. Yeah, 66 bytes. Here. Header length is 20 bytes. Total length is 43 bytes. What is the data size?
23
23.
bytes.
23 bytes. Let's see something here. Okay, what is the data that they are carrying out in this particular data packet? So the header length again 20 bytes, total length again 300 bytes.
280 bytes.
280 bytes, yeah, exactly. What is the values that they are carrying out in here? It says 20 bytes on the header length, 202 bytes on the total length. Simple mathematics. Maths 101.
182.
100?
82.
Exactly. Okay, here we go. The data size that we are carrying out in this particular data packet, in this particular IP header. 20 bytes of the header length, total length of 170 bytes.
1050
1050.
bytes.
1050 bytes, yeah, exactly. The size of the data packet that here we are carrying out.
1045.
1045.
Yeah, 1045. So likewise, you might clear that. So by looking at this total length and by looking at the header length, you will be able to calculate, definitely you can be able to calculate the size of the data that are carrying out by this particular data packet. Are you clear, guys?
Yes, sir.
So you can see in practical scenarios, none of the packet are exactly carrying the 1500 bytes. Of course, that is cannot be because yeah, that is none of the packets are in here in the practical scenario. They are exactly carrying out the 1500. I just want to show you another interesting thing. This is again the sort of interesting concepts. You will be seeing that in here, the packet frame size is 311 bytes. The frame size in the sense total data packet size, which is including all the headers, TCP IP header, IPv4 header, data size, and then again the yeah, everything. So all the things, while including everything, you can see that is 311 bytes. If you see here, when you look at here, the total length is 297 bytes. If you deduct these things from the 311 to the 297, what is the exact amount of here? What is the exact amount? When you look at the value of this, when you deduct these things, 211 bytes and the 297 bytes, it's a 14 bytes. If you look at here, the 14 bytes, that 14 bytes will be added by the frame, this particular frame. This is what they are going to do, or rather we call it as Ethernet. If you look at here, exactly 1, 2, look at this. When you highlight here, just look at here in the Ethernet adapter, look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, exactly 14 bytes. For the Ethernet adapter, that is for the data link layer, they are going to add another 14 bytes of the frame headers. Is it clear, guys? That is from the data link layer. Once you send the data packet from the network layer to the data link layer, they are going to add another 14 bytes of header to the data packet. Are you clear, guys? This is exactly, if you can count this highlighted area, if you can count this, can you see this highlighted area by the this one? May make a, this is, we are going to change it, but this one. So the bottom highlighted one, can you see that one? Exactly this, I told you that 2 letters will be equal to 1 byte. So you can just count it exactly having the 14 bytes. Are you clear, guys? Guys?
Sir, can you explain Sinhalese? For
Yeah,
little.
yeah, exactly. I will explain it. What about the others? The people who, Tamil and the Muslim people, are you clear with this? Or do I need to explain it again?
Could you please explain that 14 again,
Yeah,
sir?
yeah, sure. So just keep this, look at this. I just want to highlight here some extra thing in here. You can see that the total length of the data packet here is 297 bytes, right? If you look at the frame, when you look at the frame, it contains 311 bytes. Frame in the sense, when you sending the data from the OSI layer, which we have discussed, so they are going to add the different type of headers in each and every layer. So they are going to add the TCP IP header. So you can see this is the TCP IP header, that what they are having the say data, TCP IP header. You can see that TCP IP header, and then you are going to say like the user data protocol. This is the TCP IP header, and this is the IP header. The third layer, you can see that different type of header information. So I'll show you that one. This is what we call it as a data, 269 bytes. This is what we call it as a TCP IP header. This is what we call it as a IP header, and then they will be adding the Ethernet header as well. If you look at in this particular data packet, on the top of the frame, they are saying the size of this particular frame. Oh, because the data packet will be encapsulated with the different headers, like from the, when the data packet going from the top to bottom, because they are sending from the application layer to the data link layer, and through the physical layer to the other part. So from the application layer, when they are going forward from the application layer, they are going to add the different headers from the top to bottom. So first they will add the TCP IP header, not in the application layer. They are not going to add anything. They will be at the TCP IP header. Then they are going to add the IPv4 header. And finally, they are going to add the frame header, that is called the Ethernet header. You can see the final list. They are saying the size is 311 bytes, 311 bytes. If you look at the 311 bytes, and if you see here, it says 297 bytes, 297 bytes. So what they are saying is, you are having total length of, including the IP header plus the data, that is contained 297. But if you look at the frame, it says 311 bytes. When you reduce this 311 bytes, hope you can see this one. When you reduce the 311 bytes from the 297, that is including the data plus the IPv4 header, it says 14 bytes. So the extra 14 bytes they have added while they are sending the data packet from the network layer to the data link layer, that is the header given by the Ethernet layer or the data link layer. If you look at the size of this one, exactly you can count from here 1C to 00, 1C 20 dB. Just count this 1C very much equal to two digits will be equal to 2 characters will be exactly equal to 1 byte. So because one character will represent here is the 4 bits. So the two characters in the sense that is representing 8 bits, that exactly equal to 1 byte. So just count 1C is a 1 byte, 2 byte, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and until up to the 0, 0, that is 40. Are you clear, guys? So you can see that is also there. Are you clear, guys?
Yes, sir.
Yes, sir.
So everyone is clear with this, right? Okay, do you need this English explanation as well?
If you
Yes,
can,
sir.
please do, sir.
Right, okay. So මේක වෙන්නේ දැන් data packet එක මුල ඉඳන් උඩ ඉඳන් ඒ කියන්නේ application layer එකෙන් ඉඳන් පල්ලෙහාට යනකොට data link layer එකට යද්දි data link layer එකට යනකොට data link layer එකට යනකොට ඒකේ 7 layers 7ක් තියෙනවා. ඒ layers 7 application layer එක තියෙනවා, application presentation ඔහොම layers ටික තියෙද්දි ඔය TCP IP layer එකේ ඉඳන් ඒ කියන්නේ හතරවෙනි layer එකේ පල්ලෙහාට එනකොට 4 3 2 1 ඔතෙන්දි තමයි headers add වෙන්නේ. එතකොට හතරවෙනි layer එකේදී TCP IP header එක add වෙනවා. තුන්වෙනි layer එකේදී IP header එක add වෙනවා. දෙවෙනි layer data link layer header එක add වෙනවා. data link ඒ කියන්නේ second layer header එක add වෙනවා. එතකොට ඔහොම තමයි මේ තුන යන්නේ. එතකොට මේ තුන යද්දී ඔයාලට දැන් TCP IP header එකයි data link එකයි TCP IP header එකයි IP layer එකේදී headers add වෙනකොට ඒකේ sizes තියෙන කේකේවා. එතකොට IP header එකේ size එක එන්නේ එතන IP header එකේ size එක බැලුවොත් 20යි byte size එක ඊට අමතරව data ටික පෙන්නනවා total length එකේදී. දැන් ඔයාලා මේ total length එකයි මෙතන frame එකේ size එකයි බැලුවොත් එහෙම මේක 311 bytes එනවා. total length එක 297 bytes එනවා. එතකොට මෙතන පැහැදිලි වෙනසක් තියෙනවා 311 bytes වලයි 297 එකේ 14 bytes වෙනසක් තියෙනවා. මේ 14 bytes එක කියලා කියන්නේ හරියටම මෙන්න මේ Ethernet header එක. ඔයාලා දැන් මේක පල්ලෙහා count එක ගත්තොත් එහෙනම් 1C 20 dB මේ ටික මේ කෑලි දෙකක් 1 byte නේ. characters දෙකක් එක byte එකයි. 20 කියන්නේ characters දෙකයි byte එකයි. dB කියන්නේ characters දෙකයි byte එකයි. 51 කියන්නේ characters දෙකයි byte එකයි. So if you look at these things මේ ටික එකතු කරොත් එහෙම 1 2 3 4 5 6 7 8 9 10 11 12 13 14 හරියට මේ ටික එකතුව 14 bytes එනවා. ඕක තමයි ඔය frame එකේ size එක තමයි උඩ 311 bytes තියෙන්නේ. ඒක අඩු කරොත් total length එකෙන් මෙතන තියෙන එකෙන් ඔයාලට හරියට frame එකේ Ethernet frame එකේ size එක ඔයාලට ගන්න පුළුවන් data packet එක. Is it clear, guys?
Yes,
Yes, sir.
Okay. So this is actually that we will be going to look at this particular concepts like what we are going to do it in here, right? So we have already learned the version, header length, service, total length, and what we are going to learn is identifications, flags, and the fragmentation offset. So there are another few fields that we are going to learn it. So which is we will be not going to discuss today. Definitely we will be going to discuss on somewhere on most probably. What about the Tuesday, guys? Next Tuesday, are you okay to do the lectures?
Tuesday evening we having web programming, sir, as usual.
Okay. Wednesday?
Wednesday, no problem, sir.
Okay, right. So then we will be going to have the next class on the Wednesday, and then apparently then following the Thursday as well. So we are going to have the next Thursday and the Wednesday classes. Definitely within that 2 weeks, we will be going to complete this particular chapter with the assessment as well. So next within the next 2 days of time, so we are most probably we will be within Wednesday if you because when you're dealing with this you might counter several issues, so then we need to clarify then and there, so that might drag the class. But anyway, most probably next week we are going to finish it off this particular chapter along with the what we call along with the simply along with the assignment. So that is going to be the plan that we are going to do on the next week. So okay guys, so hope you have cleared up to now. So then we will meet on next Wednesday at 4:30. So I'll give you the link and on Tuesday, so then we can join it on the sessions. Okay, guys.
Yes,
Okay.
sir. Thank you.
Thank you, sir.
Okay, we'll meet on
Sir.
next.
Good night.
Right, sir.
Thank
Okay.
you, sir.
Okay. Bye. Stay safe, guys.